Hi, welcome back to Moose and Chemistry. This is Charles Gaslaw, lesson number 1. Let's look at our pressure unit conversions. Our flow, 760 millimeters of mercury is 1 atm, which also equals 760 torr, which equals 101.325 kilopascals, which equals 101,325 pascals, which equals 1.013 bar, which equals 14.7 psi. The STP is at 0 degrees Celsius in 1 atmosphere. 1 millimeter of mercury is equal to 1 torr. And remember that Kelvin is K equals C plus 273. Charles' law is normally V1 over T1 equals V2 over T2, but it's better to do it as V1 T2 equals V2 T1, and pressure is, of course, the constant. All right, let's look at the first problem. A man heats a balloon in an oven. That guy must have some serious issues. If a balloon initially has a volume of 0.4 liters and a temperature of 20 Celsius, what would the volume of the balloon be after he heats 250 degrees Celsius? Okay, well, now, let's see here. The initial volume is 0.4 liters, okay? And the temperature was at 20 degrees Celsius. And he heats it up to 250 degrees Celsius, and we want a new volume. Well, we can't use Celsius. We have to use Kelvin. So K equals 20 plus 273.15. So our T1 temperature for Kelvin is going to be 293.15 K. All right, our second temperature, of course, is going to be 250 plus 273.15. So our new T2 temperature is going to be, let's get a calculator here. We go 250 plus 273.15, and that equals 523.15. 523.15. Okay, all right, now we're ready to solve. To solve this, we have to isolate for V2. So V2 equals V1 T2 over T1. So V2 is going to equal our first volume, which is 0.4 liters, times our second temperature, which is 523.15 K, divided by our first temperature, which we found to be 293.15 K. So our K's cancel out, and we just simply do the math to get our V2. So we go 0.4 times 523.15 equals, divided by 293.15, which equals 0.71 liters. Pretty snarly, huh? So let's take a second problem here on this issue. On a hot day, you may have noticed that a potato chip bag seems to inflate even though they have not been opened. If a 250 milliliter bag at a temperature of 19 degrees Celsius and I leave it in the car, which has a temperature of 60 degrees Celsius, what will the new volume be? Well, the original volume is going to be 250 milliliters. So we're just going to do that there. And our original temperature was 19 degrees Celsius. And our second temperature was 60 degrees Celsius. Well, we're going to change our temperatures. So let's go ahead and use the space over here to do that. So K is equal to 19 plus 273.15. And so our T1 temperature will be the same as, we go 19 plus 273.15 equals 292.15. 292.15 K. Our second K value will be, of course, 60 plus 273.15. So our T2 temperature is going to be different. It's going to be 60 plus 273.15, which gives us 333.15 K. So 333.15 K. Now we're ready to solve the problem for V2. All right, so we isolate for V2. V2 equals V1 T2 over T1. So V2 equals, of course, 250 milliliters, and we can leave it in milliliters. All right, times our second temperature, which is 333.15 K, divided by our T1 temperature, which was 292.15 K. K's cancel out, and so our V2 is going to be, let's go ahead and do the calculator here, 250 times 333.15 divided by 292.15, and that gives me 285.08 milliliters. Well, that's it for this lesson. You guys be snarly. I will see you back here at Moosine Chemistry.